Hello everybody, this is Zareian from Power Electrical Developing Advanced Research Group. In this short training video, I'm gonna talk about online monitoring and control of a grid-connected power DC microgrids. In this video, I will discuss about power management in DC microgrids in online simulation. Also, I will discuss about how to control battery mode in an online real-time simulation. Actually, in this video, I'm gonna talk about different parts of a power DC microgrids, including different type of generation units and DC demand loads. Also, I will discuss about how to control and manage the output power of each generation units with the aim of improving voltage stability when a disturbance such as generation outage or demand changing happen to a power DC microgrids. Like the previous training video, let's go to simulation, which is prepared for you in this study. For example, if you want to call these simulations file into your Matlab software, it's enough to copy the address bar from your computer and paste them in your address bar of the Matlab software. By pressing the key enter here, all of these simulations file is called here. So if you want to open the simulation file, you can double click on your desired model of simulation files based on your version of your Matlab software. The simulation files for Power DC microgrids is open. As you can see here, the Power DC microgrid is consist of two main bus number 1 and main bus bar number 2, where these two bus bar are connected to each other through these short lines. Also, these two bus can be connected or disconnected to each other using these state switch mode. By turn on and turn off these switches, we can connect to these bus from each other. Also, as you can see here, in the main bus bar number 1, we have a slack bus, where the slack bus, the main component of the system that is responsible for controlling the voltage, where this slack bus connect to the main bus bar through this short line. Also, as you can see here, another component of the system, such as demand, PV system, and battery, connect to the main power bus bar number 1 through these short lines. Also, each component can be connected or disconnected from the main DC bus bar using these state switches. For example, if you turn on or turn off, you can connect or disconnect this component from the DC power system, or connect and disconnect from the DC PV system using this turn on or turn off. Also, as you can see here, the battery is connected to the main DC bus bar number 1 through this short line. As you can see here, the battery model with full model of the battery, which are regularly used for these studies, is modeled here and simulated here. And you can see this battery can be charged or discharged using this dual active bridge, which is prepared here. So you can change this button for changing the rules of charge or discharge in the battery. As you can see here, you can see different components of these bridge for charge, this dual active bridge for charging and discharging mode of the battery. In the another side of the simulation, we have a meter gauge that show us the voltage of the system and stability voltage of the system, where the system voltage reference is between plus 375 and minus 375, totally of 750, as you can see here. Also another gauge that show us the output power of absorbing or injected power by the slag bus, where the minus value is used when the slag bus absorb the power from DC microgrids. Also the positive side of this meter is used when the slag bus inject the power to the AC into the DC power microgrids. So as you can see here, this is the curve of the online simulation that show us online behavior of each component of the system, such as demand power, PV power, battery power, and another power of the another component of the system. So during of the online operation and online simulation, we can see output power in online real-time simulation. For example, when you run the simulations file, when a slag bus is on in the system, demand is on in the system. Also another component of the system is connected to the system. You can see different state of the each component. Also online power, output power of the system, as you can see here. By changing the state of these switches, we can make different scenario of the operation for these simulation. For example, in the first state, we can see the slag bus power is close to the 0 values because the PV system can support the demands of these power system and battery, which is connected here. So if you turn off these, as you can see here, the voltage is stable in values of 750. If I turn off this demand and disconnect this demand from the system, as you can see here, this demand is turned off and the output power by the slag bus start to absorbing power by the system, because the PV system can support the battery and the remain of the power by removing this load absorbed by the slag bus. Also, if you look at this system and turn off this connection bus, we can see the power which is absorbed by a slag bus is increased by the slag bus, and the voltage is stable. Also, if you look at the battery charge mode, we can see the battery is start into the charge stable mode. However, if you turn off the battery, if you turn off the PV system or disconnect the PV system from the main bus, as you can see here, the red curve of PV system is reduced to 0 and the slag bus go to the positive value that show us the slag bus inject the power with the aim of control the voltage in the PV system, in the DC system. So if you, as you can see, if you turn on demand, again, when the PV system is disconnected from the system, the PS lag is increased. For example, if I turn it on, as you can see here, the output power by the slag bus is increased to this point, and the voltage is a stable point. As you can see here, the battery start to charge and receive the active power from the system. In this state, just a slack bus is responsible for controlling the voltage. So if I turn off the slack bus where the PV system is in disconnected mode, I can see the behavior of the system for short time interval, because I expect that the battery can control the voltage for a short time interval as a low inertia generation units that want to control the voltage in this study. For example, if I turn off the slack bus or disconnected it from the DC power system, as you can see, instability on voltage is start and the output power is 0 by the slack bus, and for a short time interval battery try to control the voltage. But as you can see here, the battery start to discharge mode, go to discharge mode with the aim of control of the voltage. But as you can see here, if you look at this state, you can see the output power of the battery is a start to reduce. And as you can see here, the battery can't control the voltage for long time interval. So if I turn on the slack bus, the system gets back to the stable point and the output power of the slack bus per some transient, as you can see here, some transient of the system is happened to the power DC microgrid with the aim of reaching out to the stable condition. Also, as you can see here, you can see the bus voltage of the reference voltage of the system in this display monitor. Also, you can see each part of the generation units curve by pressing double click here. You can see different state of operation for these simulations. So as you can see here, you can change different state for these suites and focus on different scenario that you would like to continue them in your desired model, and change these state switch for outage or intage of these simulation for each generation units by changing these switches. For example, if you want to connect another DC load by changing this switch to on mode, we can see the demand is increased, so the slack bus must be increase the output power that it injects to the DC power microgrid with the aim of control of the voltage. So as you can see, you can study different state of operation for a power DC microgrids for different scenario. If you want to download this simulation file along with 1000 simulations file related to another project, you can go to Telegram application and subscribe our channel with this address at Power Matlab, and you can download 1000 simulation files related to another project related to power microgrids or power systems. Thanks for your attention. Bye for now.